Hello there. We are students from BINUS International, Jakarta. And today we would like to give you a video presentation on our final project. We are information system students from batch 2019. And our final project is a database system of Dungeons and Dragons Online. So before we go into all that, let us introduce ourselves first. My name is M.Rifqi Nabih Didi. This is my friend.
I'm Jason.
And this one is...
My name is Aldo.
And this one...
My name is Rifki.
And we are going to talk to you about introductions on what is Dungeons and Dragons Online and the database that we use, the normalization that we are going to use, and also finally the database models and sub-queries and also queries that we are going to use. Okay, so let's get started.
First of all, I give you a brief presentation on the tables that we are using and a little bit about the relationship of the tables. This is all the tables that we are using. We have created these tables based on our observation and research from the YouTube video and Wikia. There are 4 main tables consist of character, account, look, and slot. Each table is related to another relevant table. For example, look related with the table's nose, hair, lips, eyes, and face details. The next thing that we want to discuss is database models. There are 3 types of database models. Here are conceptual, logical, and physical database model. First of all, I'm going to explain the difference between conceptual, logical, and physical. Basically, conceptual just shows the name of the table and their entity relation without providing the content of the tables. The content of the tables is provided in the logical and physical. Logical shows exactly the same as conceptual, but it has the content of each table, whether physical consists of attributes each content in the table. So, conceptual database model is a prototype of the database model, but consists only of the table's name and which table it has relationship with. And now, for the logical database model, it's almost the same as conceptual. However, it also has the primary key and foreign key of said tables. But most importantly, it also provides the column name of the tables. The physical database is exactly the same as logical, but with an added attributes to explain the full capacity of the finished database model.
Now we will explain about the entity relationship for all database models. Let's start from the relationship of eyes tables and look table. Eyes belongs to one to many look because any character that is created can have the same pair of eyes, whereas in the other hand, one look can only have one and only one pair of eyes. This relationship is valid also with other similar tables such as face details, nose, hair, and lips. Then there is another relation between a look table and character table. A look belongs to one and only one character because look is what differentiates a character with other characters, whereas a character can only have one and only one look. For both race and fits table, they belong to one to many character because any character can have the same race and fits, whereas a character can only have one and only one race and one and only one fits. Moving on to the skill and character relationship, one type of skill belongs to one to many characters. The reason is because more than one character can possess the same type of skills. However, one character can possess one to many skills. Continuing, a pet can belongs to one to many character since there might be more than one character that is created to have the same pet, but one character can only possess one and only one pet. Then we will move on to the relationship between the style and class table. Also the relationship between class table and character table. One style can belong to one and only one class, and one class can possess one and only one style. One class belongs to one to many characters because many characters can have the same type of class, and one character can have 1 to 3 class because there is character that can possess multi-classes ability. Next, we will look into the relation between stat table and character table. One stat belongs to one to many characters, but one character possesses 6 to 6 stats because each character owns all the 6 stats. Moving on, we will now discuss the most interesting relationship in this database, which is the relationship between accounts and character. One account has the ability to have 0 to 6 character creation, whereas one character that is created can only belong to one and only one type of account. One slot belongs to many accounts, but all accounts, whether it's free to play, premium, or VIP, they all have 2 and only 2 regular slots. However, there are bonus slots that vary from 2 to 4 depending on the account type, whether it is premium or VIP. The premium will have 2 regular slots and 2 bonus slots, whereas the VIP will only have 2 regular slots and 4 bonus slots to store their characters. This is why one type of account has 2 and only 2 regular slots, and one slot can be owned by 1 to 3 type of account. Last but not least, one bonus slot adds 0 to 1 many slots, but one slot can be added by 2 to 4 slots.
Okay, before we get into the normalization itself, first we need to know what is normalization. According to studytonight.com, normalization is a technique to organize data in a database. It could also be called an approach of decomposing tables to eliminate data redundancy and anomalies. Data normalization itself has 4 categorization. The first one is UNF or unnormalized form, which is the regular form. The second one is the first NF or first normal form. The first NF does not have repeating data. The third form is the second normal form, which has no partial dependency on primary key. The last one is the third normal form. The third normal form is that every non-prime must be dependent on a primary key. Okay, now that we have classified the normalization, now let's get into the Dungeons and Dragons online normalization. Okay, for the first normalization, we will use the table accounts. Okay, as you can see, this is the unnormalized version or unnormalized form of the table accounts. It has user ID, front name, last name, username, email, phone, and slot ID. Okay, for the first normal form, we can also see that it is not different than the unnormalized form because it has no repeating data, therefore it is also the first normal form. Now for the second normal form, the second normal form of these accounts also consists of the third normal form because as you can see these are the 3 main tables of the normalized version. Let's look into each and one of them. The main one is this one, the accounts. It has user ID, user details ID, and username. The user ID or user details ID consists of details about the user, while the username consists of details about the accounts. Also, the user details ID and the username are both foreign key. Now, for the account user date or details, we have the account user detail ID, front name, last name, email, and phone. This is the data consists of the user's data, with user.id as the primary key for the table accounts for this account. Okay, now for the other table, the account details, this one has username and slot ID. The username is the primary key and also the foreign key on the table account, while on the table account details it is the primary key with slot ID as its other column. Okay, now we will talk about the second normalization that we used is the character normalization. As you can see, this is the unnormalized form, or the also as the case with the first table, which is accounts. This unnormalized form is also the first normalized form, as it does not have repeating data. It is also consists of the first normalized form. Okay, this is the second normalized form of the table characters. Here I split the tables into 2, character account and character detail. The character account have character ID and user ID. Character ID is its primary key and user ID is its foreign key. And the second one is the char det, or also known as char details. This one have character ID, character name, class ID, path ID, race ID, skill ID, fit ID, look ID, hair color, eye color, lips, and stat ID. This one uses character ID as its primary key. Now this is the third normalized form. As the third normalized form of this table also uses the second normalized form, the tables used on the second normalized form, but also used an additional table. Also used additional tables to provide more support. As we can see, we have the chardet, also known as chart details, the character appearances, and the character progression details. The first one is character details. Character details consist of character ID, name, progress ID, and appearance ID. This is the main table of the third normalized form, as the character ID as its primary key and prog ID and appear ID as its foreign key. Okay, this is the char app or char appearance, character appearance. We have appear ID or appearance ID as its primary key, with look ID, hair C, eye C, lip C, all means color, and stat ID. Look ID is a foreign key from another table. Okay, now we have the char proc det, or also known as character progression details. This one have the proc ID also used as the primary key, also used as a foreign key in the main table. This one also have the class ID, path ID, race ID, skill ID, fit ID, and stat ID. Everything you need in a character progression. That is it about the normalization. And also the reason we use only 2 normalization tables is because it is quite impossible to use 5, as the other tables are all already normalized in its primal form. As it is impossible to create 5 normalized form, it is only possible and plausible to use 2 instead of 5. Okay, this is it for my presentation on the normalized form, normalization of the tables.
This is the 4 queries that we use, and I will go through them one by one. Now, this query searches from the column style name from the table class, which is then grouped by the column style name. And for the count, it counts the style name and sort it accordingly, and you can see the result here in the screen. And for this query, it selects the character ID, character name, and the user ID from the table characters, and having it grouped by the user ID. It will then display the column selected which has more than one user ID, and you can see the result here. Now, as for this query, the first and the second is the same as before, but the differences is it selects from the where the maximum user ID existed, as you can see the results here. And now the next query creates a few name, account, character detail with the columns character ID, user ID, and character name from the table characters. It is then grouped by the user ID and sorted in ascending order by the character ID, and you can see the results here. Last but not least, we use join to combine the columns from different tables. In this case, we choose the user ID column from characters table, F name column from the counts table, and the L name columns from the count table, and character's name from the characters table. And you can see the results here. And that's all from me.
A database is used to collect and organize and store data. It also shows the relationship between tables of data that are related and ties them with keys, primary keys and foreign keys. The database in this character creation system collects and organizes data that is used to create a new character, such as looks, accounts, stats, feats, path, and etc. The stored data will remain in the database, so every process of character creation will be based on the database.
So for the procedures of this group project, of our final group project, is that first we watch the video on YouTube, the character creation video, and after that we read the wikis related to the character creation, such as the accounts, the characters. And what we do after that is that we assign each one of us an assignments with a deadline, such as creating tables, searching for the values to be inserted, and planning for the database modules and normalization. And after that, we each finished our task before our deadline, and on the deadline we met on BINUS in order to create video to be uploaded to YouTube. That is for That is the procedure that we went through for this group project.
That is the end of our visual presentation on the group project of Dungeons and Dragons Online, and this is also the end of our video. If you have any comments or questions, do comment on the comment box below, or feel free to drop us an email. And thank you for watching.
Thank you.
Thank you.